In this video, we're going to get started with creating our defend objective state. In this state, the AI is going to go and find an objective to go to. It's going to defend that objective by walking around it, kind of like guarding it. And then if the player actually picks it up, the AI will react at that time. The AI will not react until the player actually steals the item. Now you can change the code however you like. If you want the AI to react within a range or when he just sees them, you could have obviously that going on. But I wanted to bring something a little different into the game than just simple, see and kill type of intelligence with the AI. So to get started, we're going to go inside of our puz enemy start point, and we're going to create two variables: a variable bool called b should defend, and a variable bool called b find random object to defend. Both of these are editable in the map editor, hence the parentheses, and they're both under the category AI Intel. This is going to allow the level designer to decide if that creature should defend or not. And also, if it decides to make it find random objectives to defend, it can set that as well. If it decides not to find a random objective, it will find the closest objective to defend. Most of the time, the level designer is probably going to want it to find the closest objective because she's probably going to place the AI near it, and and want it to defend that item or whatever it is it's defending. Okay, so then we go to puz enemy start point shooter mob, and we're going to set the b should defend the true. So we're going to automatically make shooter mobs defending mobs. If you decide you don't want to put this in there, you can. It's up to you. But just make sure you go into the start point and change it manually then to b should defend if you want this code to work. Then we go inside of puz enemy information, and we create a variable bool called b force defend. What that is that's going to basically say that the coder is overriding the level designer's option and saying that this creature needs to defend no matter what. This could deal with certain special mobs that aren't meant to wander around unless absolutely have to. Okay, so now that we have all that out of the way, we can go inside of our puz AI controller, and down a little bit we created multiple variables here. We'll go over each one right now. We have variable bool b defender. This basically is what we grab from our AI start or from the puz enemy information if it's a force defend, and we set this if it is an actual defending AI. Then we also have, of course, the find random object as well. We set this as well if it's supposed to find random objects through the start point. Then we have object to protect, which is an actor. This is the object that the AI is meant to protect, which is going to be, in our case, the objective items, the puz objective items. We did not create this code to work outside of that, but you could essentially manipulate the code just a little bit to make it work for just about any actor if you wanted it to. Then we have variable vector object defend goal points, and what this is when the AI gets to the objective to defend, this creates a circle radius of points that the AI will walk to while it's walking around defending the object. Then we have variable integer num defend goal points, a float called radius from objective to defend as well, and both of those deal with creating the circle. The defend goal points is how many points along the circle we're going to create. This is the outer edge of the circle. This is so how far out, and then or how many of those you have, and then the radius is how far out you go. So that sets basically how big the circle is and how many points in the circle that the AI will walk to. Down in the default properties here, we set num defend goal points to 8 and radius from object to defend 256. Now 256 is not a big radius, but it's a decent radius that we don't want him to go too far off because if he can't see the objective, he won't go to that point. We made it so that he only stays within the line. He wants to make sure he stays within the line of sight of the objective. Otherwise, he's not really guarding it very well. Back to the top, we have B defender alerted. And this is what happens if you do pick up the item. It alerts the defender. He becomes angry at you, and he will not be your friend anymore in the rest of the map, unless it gets restarted because the player dies or the enemy dies or whatever. But the defender will not be happy with you anymore at this point. So once you grab the item, he will then attack you on sight no matter what. Okay, now to get started, we need to go inside of function initialize because that's where we're going to set some of these variables. Because they come from the start point, we're going to start off with if ESP is not equal to none, which is what we pass in our enemy start point. And if it's not equal to none, we set b defender equals to b should defend, and b find random object to defend to esp.b find random object to defend. So we're just going to grab that information with the map that level designer decided for us to have. If it is a force defend issue, Then we're going to also set B defender AI info dot default dot B force defend. So it's going to basically override the level designer if it's supposed to be forced to defend. After that, we need to make sure that we go into our defending state when the game starts. So on restart, like we normally would go to wandering, this time we're going to do a check where we say if B defender is true, or if it's false, we go to wandering. If it's true though, we go to our defend objective state. And that's going to get us started. So that's going to be all we really need to do in order for our AI to act in our defending state. So now we need to go to our defend objective state and start talking about that. Now there's a lot to go over, and I need to find the beginning of it. And what we're going to be doing is we're going to start from the top bottom in the functions, and then I'm going to talk about the total workflow after we're finished. We start off with our function C player, which basically is like our other C players. It checks to make sure there's not a blocking volume. If there is, then we don't do anything. If there isn't, though, we set the enemy to the scene player and we go to state attacking. We also have here noise, which goes to the state check noise location. These two really haven't changed at all. Maybe a little added code of next location to goal equals herd location, but outside of that, nothing really has been changed too much, if anything. Then we go to our find closest objective to defend. What this is this is going to actually find the closest objective to the AI pawn. So it's going to grab all the objective items out there. It's going to make sure they're not disabled, because if they're disabled, that means they've been collected already, so there's no point to going to them. And we're going to create an array of these items. And then what we're going to do is we're going to check to make sure the array is not less than or equal to 0, because if there isn't any items out there, then there's no reason to defend. So we're going to return. We're also going to set B defender to false, because if there isn't any items, he doesn't need to defend anymore. He might as well go to the wandering state. And then object to protect will equal none. The reason why we set B defender to false is because in our other states that we'll get to later, we check to see if it's a defender, because when it leaves the attacking state, we want to make sure it goes back to the correct state. So we do a check with this B defender. And that's the reason why we set it to false, because if there's nothing to defend, he might as well go back to wandering. So it kind of defaults back to the wandering state. Then inside of, if there is a length in our array, we do a list, we do a check on the length, and we basically do a for loop through the dynamic array. And we start off by saying if I is equal to 0, which means that's the first item in the array. Then we're going to do object to protect is equal to the object array 0. Lowest distance array is 0. So what that basically does is that gets us on our starting point. Then from there we check every single one and compare it to the lowest distance array. If the object distance is I, which would be, let's say for instance, array number 1 now, is less than object distances and then the lowest distance array, which currently is array 0, then we're going to make that one take over. And we're going to set object to protect to equal to that array, and we're also going to set the lowest distance array to I. Now, the reason for this is because now we can reuse that, and we just constantly loop through and check to find the lowest distance. And every time we find a lower distance, we replace the object to protect. Once we're done, we have our object. We would then call decide moving path to objective, which we'll get to later. Then we have function find objective distance. And what this does is this is what we're calling here, which basically checks the distance, and it's kind of like our enemy distance check, but we're just casting in an actor instead of a pawn. Then we have find random objective to defend. Now this is what happens if the AI or the level designer decides to make it a random search, and basically does a lot of the same code. It starts with doing, once again, the loop to create our list of array objects. Then it checks to make sure the length of the array is of at least it's not 0 or less. If it is, it does the same thing as before. And then we do a range choice where we do a range from 0 to the length, and then we do the object to protect is equal to whatever that random number is, and then we call on decide moving path to objective just like we did in the other one, which we'll get to once again in a little bit. Okay, so then we have function bool find path to objective, which gets called right off the bat inside of our decide moving path to objective, which is what we're going to get to. In here is a lot like what we've done before. We just set our path toward and for our constraint, and we set our goal to the at, and we just basically go to that object. So this, we'll basically set our goal and constraints so that we can then use our nav mesh and find our way to the objective we're going to protect. If the find path to objective returns true, then we do a lot like we normally do. We set the nav goal location to the object to protect location. We set the final destination to that nav goal. And then we do a check to make sure that the actor is reachable. And if it's not, we kind of move along the path and find our way to that object. A lot of this is stuff we've already done. We just kind of changed a few variables here and there to make it work for our current situation. So then we also have set next location and path, which once again does what we've done before, just gets that next location on our way to the goal. Next we have check objective to defend, and this gets called right away in our begin state when we first enter, which like I said, we'll talk about that in the workflow. What this all it really does is it checks to make sure it's a random objective to defend, and it also checks to see if it isn't a random objective to defend, then it sets it to the closest objective to defend. And that calls on those functions we talked about just seconds ago. Finally, it also makes sure that if there is an object to protect, it's not equal to none, then we also create our goals around the objective. This creates that circle of points that we can have our AI walk to while it's trying to guard the item, which is right here. So we have function create goals around objective. In here we have starting point equals object to protect, and we also have location to defend object to protect location as well. What we're basically doing is some trigonometry where we're creating a circle and moving along points in that circle. So, for those of you that don't know trigonometry, it's not like it's a requirement or anything like that for you to know how to code. It's just if you ever want to use some sort of information based on circles, it's important that you kind of get a grasp of it. I'm not a trigonometry expert to even give the slightest type of help on that type of situation. So I would strongly suggest you look up the, how things work on your own. But basically, what we're doing here is we're grabbing we're basically grabbing the full circle around it, and then we're dividing it in the number of points that we've created. So, and then what that then does is allows alpha to move through each point individually, and we set that point based off of the beginning code, based off the full circle that we have. But like I said, it's for those of you that know trigonometry, obviously you can read this and say, oh yeah, I got this 100%. For those of you that don't, I strongly suggest you look up and read up on trigonometry if you want to learn exactly what's going on here. But here basically creates that circle for us. Okay, now what we're going to do then is we're going to create an array as well that's going to set the object defend goal points so that we can then use that as we're moving along throughout our area of the objective. So when the AI basically when the AI gets the objective, it's going to say, okay, where do I go from here? And that's what the object defend goal points come into play. We end up using a random objective defend goal point to decide where it goes. Now you could, if you wanted to, have it actually walk around in a circle, as if it's like circling the objective, and you could do that, but in our code we didn't do that. We just have it choose random spots, and it just kind of moves around randomly. Next we have function bool objective taken, and what that is that checks to see if the object was taken, and that's kind of like a check area. And if it was taken, it obviously has been disabled, so we return true. If it hasn't been taken, we return false. And that lets us know if the AI should move on to a different objective, and also eventually become alerted. We have function reset defend state, which calls on check objective to defend, which basically means that if the item was taken, rather than have the AI sit there blindly not knowing what to do next, we tell it to go find another objective. Now obviously if he sees the player after the player picks up the item, he's going to go to attacking, so he won't need to rely on this. But this helps if the player manages to sneak in and grab it and run out before the AI even knows it's gone. Then we have function find thief, and this is where we set the be defended alerted to true, defender alerted to true, and then we also enable the ability to hear and see, which means that the AI will now try to seek out you and attack you, or if he hears you, he'll also listen and go to that location. Then we have function sentry objective. Now this is the function that actually decides where the AI will move around the objective. Here we do our RAND choice again, where we grab a range based off of our object defend goal points, and whatever that end up choice is, that sets to our nav goal location. If the point's reachable, we set that to next location to goal. Now here we're not using the navigational mesh because we're talking about a very small area. And when you talk about very small areas, the mesh may not do its job. So we really don't need it anyway because we're not really pathfinding at this point. We're just kind of telling it to move in little location around it. So we don't really need the mesh in this case anyway. So we're kind of doing this fully on our own. Um, and also we do a check that's basically to make sure that if we can't reach that point, if we can't reach that objective, the object defend goal point in that circle, if we can't reach it because a wall's in the way or it's out of bounds or whatever reason, we remove it from our choices. And if our choices drop lower than 2 or at 2 or lower, then at that point we're going to reset our objective goal points, and we're going to increase or we're going to decrease the radius so that he can walk. So we're going to make the circle smaller because that way it decreases the chances of running into a wall. This helps if you put an objective in a very tight corner or something like that. Obviously, you don't want the AI to just not know what to do. You want to kind of give it another, keep decreasing the circle till you get a very good amount of points that it can walk to. Um, and then, of course, if we can't reach that next location, we tell him to return to the objective because we don't want him just to sit out there in la la land. We want him to come back to the objective. Okay, and then we go inside function begin state. In here, we see if the defender is alerted. Now, if he's not, which it's set to false by default, we disable see player and hear noise. So this turns them off, much like the other one enabled them. Find thief enables them. The begin state turns them off, only if the be defender alerted is false. And then we call on check objective to defend, which we already went over. When we leave the end state, when we leave the state of our defend our defend objective state, when we leave that, we want to set the radius back to its default. And the reason for this is because if you've shrunk your radius and now he's going to a different objective because you've collected it and ran off and he went to attacking state or something like that, you want to kind of bring that radius back. So that's the point of why we would do that. Okay, and then we're inside of our begin label. And at this point, I'm going to start going over the workflow of how this all works. Okay, so what happens is in the beginning, obviously the map level designer or the coder decides if this is going to be a creature that's supposed to defend the objective. If it is, then what happens is the restart kicks in, tells it to go to our defend objective state. Then inside of function begin state we hit first, and obviously be defender alerted is going to be false right off the bat. So we're going to set disable see player and disable hear noise so he won't react to any see player or hear noise code. And then we call on check objective to defend. Check objective to defend is going to see if the objective is find a random or find the closest nearby. And if it is find the random or the closest nearby, it's going to call on that code, which creates our array of it creates our array of objectives that we can defend, and then basically tells the AI to walk there. Also, it creates our goals around the objective because at this point, after this code, after the find random objective to defend and the find closest objective to defend has ran, we already have our objective in hand. We already know what it is. Even though he's not there yet, we know what it is. So we can go ahead and create those goals right away. And that's the purpose of this. Now, if there is no objective to protect, then obviously there's no reason to create goals. So that's why we don't do it. But if there is, then we create those goals right away and have it ready for when he gets there. So down in our begin label, the purpose of the begin label is basically to navigate to this object that we're going to protect. We do a check also if the object to protect ever equals none, we go to state wandering. The purpose for this is because eventually we may run out of objects to protect, and we set that to none if we do, and this is kind of a check, like a fail-safe to get us back to the wandering state. If the pawn reaches its destination, then it goes to label sentry. If it doesn't, then it moves along its navigational path to this object that it's going to protect. Okay, so then we hit sentry. Once again, we do our failsafe, which we do if object to protect is equal to none. We go to state wandering. And then we do our check that says if the pawn.reach point nav goal location is none and the object taken is false, so the object hasn't been taken yet, we go to sentry objective. Otherwise, if the object hasn't been taken, we move to the next location to goal, and If the object has been taken, then we go to find thief and we move to next location to goal, and then we go to make decision. So what happens here? So what happens is the AI gets to its objective. We go to label sentry. It's reached its point at navgoal location at this point because the navgoal location is still set to the objective. Then it calls on sentry objective. Sentry objective finds a random location in that circle that we've created and tries to find each one of those locations, and then walks to each one of those locations. If it can't walk to that location, then it tries to find another location to walk to. If during this whole process of it walking around in this circle area that the player walks up and snags the item, then what happens is the objective taken gets caught, it gets grabbed, and we now know that because the objective has been taken, we need to go to different code, which we then go to find thief. Now what find thief does is it sets the AI to the alerted status, so now it will attack the player on site. It also enables the seeing and the hearing ability of the AI. And then when we do that, we also go to make decision, because at this point the objective's been taken, so the AI has to make a decision. If if the AI hears something, it's supposed to turn to that location and go to it. Now, also if it hears something, it goes to check noise. So it really will never hit this, but this is just in case if for some reason there's some sort of change or something doesn't work where it never hits that herd location and or never gets to that state that it's supposed to be in. So this just basically lets him move back to that herd location, and just as a kind of like a fail safe in case if something doesn't go right. Um, After it does though reach that location, if it hasn't seen the player and hasn't gone to attacking at that point, then it obviously isn't going to know what to do next. It's kind of going to sit there and dwell on nothing. It's not going to move. It's not going to do anything because there's no objective to defend. So what we need to do is we need to kind of reset that. So um, we call on check objective to defend, or we can also call on our reset function if we decide to do that as well, which allows us to go back, which basically just calls objective to defend as well. So you can do either one if you want. We just threw it in there, and then we go to begin label as well. So after it hits its herd location, it goes back to begin and finds new objectives. Otherwise, if for some reason it didn't hear anything, then what's going to happen is it's going to go to sleep for 1.5 seconds and basically find then a new objective to defend. Now you don't have to use the sleep, but I figured to give it just a second to make it seem like it's kind of thinking about what it's doing, and then it's going to go find a new objective to defend and then go back to the begin label. Now, the what we have done is inside of our attacking state, we've gone ahead and made a change to where we want to make sure that the AI goes back to the defending state after it's been in attacking, and also goes back to the defending state after it's been in the check noise location. So for state check noise location, down in the begin label, what we've done is we've done an if check that says uh, if it is a B defender, we go to state defend objective. Otherwise, we go to state wandering, because we want it after it reaches that point. If it hasn't seen anything to go to attacking, we obviously want it to go back to our defend objective. Also, in our attacking state, we kind of do the same thing in the C player, where we say that if it sees the player um, but it hits a blocking volume, we want to check to make sure if it's a defender, we go back to the defend objective. Otherwise, we go back to the state wandering. And the purpose obviously is because we don't want to go back to wandering every time, because otherwise it'll never defend another objective. Back to our defense state too. A few things to talk about. First, if for some reason all the objectives have been collected, what's going to happen is the AI is going to set the object to protect to none and set B defender to false, because as soon as there's no more objects in the array to protect, there's no reason to defend. Once this B defender is set to false, then whenever it goes to that attacking state or goes to the check noise state, it will not go back to defend state because it's no longer defender. So that kind of helps stop that from kind of looping back and forth. The other thing is we check as well. For instance, let's say the player does sneak in and snags the item, And now the creature's sitting here going make decision. Well, it's going to do check objective to defend, and it's going to return that there is no objective to defend. When we go back to the begin label, it's going to hit if object to protect is equal to none, like we set to none, then go to state wandering. So there's our fail safe there as well. We go to the wandering state. So if the player sneaks in, grabs the last objective, and sneaks out before the AI sees him, then he goes back to the wandering state. And that pretty much concludes everything we've gone over. So really at this point, the AI will walk, it'll find an objective, it'll defend the objective. If you pick up the objective, he gets angry, he'll attack, he'll follow you, do his thing. If you run away and you manage to get away from him, then at that point he'll find another objective to defend, and at this time if he sees you as you're walking to the objective, he doesn't trust you anymore, and he'll attack.